Operations with complex numbers. Let's start with the imaginary number I. I is equal to the square root of -1. So if we square I squared is going to be the square root of -1 squared. So I squared is equal to -1. A complex number is a real number added to an imaginary number like this. This is the standard form of a complex number, a plus bi. Now I'm not going to go over all about complex numbers, just the standard form, a plus bi, and the definition for I and I squared, because they will both be important in this video. So we're going to go over the operations with complex numbers. There is addition, subtraction, multiplication, and division, and we're going to go over all of that in this video. First, addition. Let's say we have the complex number 1 minus 4i, and we want to add that to 8 plus 3i. What would this be equal to? Well, just like if we had any other two binomials, we can just combine like terms. So let's combine the real numbers first. We have 1 and 8, and because we're adding, it's just going to be 1 plus 8, which is going to be 9. Next, we have -4i and 3i. So what is 3i minus 4i? That is just going to be -i. So our answer is going to be 9 minus I. Let's try subtraction. If we have the complex number 5 minus 6i, and we want to subtract -3 plus 5i. How would we do this? Just like with addition, we need to combine like terms, but we must distribute this negative first. So let's do that. -1 times -3 is going to be 3, and -1 times 5i is going to be -5i. So now it's just going to be 5 minus 6i plus 3 minus 5i. So now we can just combine like terms as before. So our real numbers are 5 and 3. If we add those, it's going to be equal to 8. And then we can add -6i and -5i. -6 minus 5 is going to be -11. So this is going to be -11i. So our final answer is 8 minus 11i. Now, let's move on to addition. We have 3 plus 4i multiplied by 7 minus 2i. So how would we solve this? Well, just like with multiplying two binomials, we can use FOIL. First, outside, inside, last. So let's do that. Our first terms are going to be 3 and 7. 3 times 7 is going to be 21. Our outside terms are going to be 3 and -2i. 3 times -2 is -6, so this is going to be -6i. Our inside terms are going to be 4i and 7. 7 times 4 is 28, so that's going to be 28i. And finally, our last two terms are 4i and -2i. 4 times -2 is -8, and I times I is I squared. So we have -8i squared. So now let's just combine like terms and simplify. So we will have 21 and then 28i minus 6i. Well, 28 minus 6 is 22, so we can add 22i here. And then we have negative 8i squared. As I said at the beginning of this video, I is equal to the square root of negative 1, and I squared is equal to negative 1. So if we have negative 1 times negative 8, we're going to be left with 8. So we can add 8 here. And finally, we can simplify all of this, and our final answer will be 21 plus 8, which is 29, plus 22i. So 29 plus 22i. Finally, let's do some division. 6 minus 4i divided by negative 2 plus I. So we need to get rid of this denominator here. And we can do that by using something called a conjugate. You may remember the difference of squares. A squared minus b squared is equal to a plus b times a minus b. So this is the only case where you can multiply two binomials and not have a middle term. And as we saw in the last example where we multiplied two complex numbers, we were left with an I in our answer because we had a middle term of I. So we want to get rid of the I in the denominator. So if we multiply by the conjugate, what that will do is it'll cancel out our middle term, and we will just have a term in I squared and a term just as a number. So here we have negative 2 plus I, so the conjugate of that is going to be negative 2 minus I. But we also have to multiply the top by negative 2 minus I to make sure it stays equal. So what is this going to be equal to? So let's do the bottom first. Since we know this is going to be the difference of squares, we don't need to do FOIL because we know the pattern. So negative 2 squared is going to be 4, and then I squared is going to be negative 1. So we will be subtracting, because this is the difference of squares, subtracting I squared. And I squared is negative 1, so we are subtracting negative 1, then we are just going to be adding 1. So now we can do FOIL over here. We have 6 times negative 2 is negative 12. 6 times negative I is going to be negative 6i. Negative 4i times negative 2. Negative 4 times negative 2 is 8, so it's going to be 8i. And finally, negative 4i times negative I. That is going to be positive 4 times I. So now let's combine our like terms here. We have negative 12. 8i minus 6i is going to be 2i. Sorry, I forgot a squared here. It's 4i squared. So we know I squared is negative 1. So negative 1 times 4 is going to be negative 4. And then we are dividing all of that by 5. So negative 12 minus 4 is going to be 16 plus 2i divided by 5. So here we have our answer, and we've combined all like terms. We can't simplify this anymore. But there is one problem. This is not standard form. As we saw previously, the standard form of a complex number is a plus bi. But here we have a plus bi divided by another number. And so that is not standard form. So let's put our answer in standard form. So let's divide each of these terms by 5 to get our standard form. So 16 divided by 5 is just going to be 16 over 5. 2i over 5 is going to be 2/5 I. So that's going to be 2i over 5. 16 over 5 plus 2i over 5. So hopefully now you have a better understanding of operations with complex numbers.